higher degree polynomial functions. Okay, multiplicities that are even, and you'll see what happens with even. Here's what happens with even. With even, the function turns at x equals -3, at x equals -3, at x equals -3. Here, degree, or it appears twice, Here appears 4 times, and of course 6 times. There's no point in going that far, but I just want you to understand. So what does this mean? It means x plus 3 to the second power, x plus 3 to the fourth power, and x plus 3 to the sixth power. It doesn't mean that it has 2 solutions. It has 1, but it appears twice. It doesn't have that mean that it has 4 solutions. The same solution appears 4 times, meaning it takes its time. It's not a straight turn. Slowly, 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 finally touches at -3 and slowly, slowly, slowly moves away from it. And here even slower because there are 6. So, odd multiplicities, cross. Straight, flat, flatter. Even multiplicities, turns. Straight, flat, flatter. Or slower, slower, even slower. Okay. These are the new additions to these functions. And now let's start the procedure of graphing a cubic function. Graphing a cubic function. Before we do that, let's look at something like this. How many turns does this function have? Oh, did I start that? Yes, I did. 1 turn, a second turn, a third turn, a fourth turn. Max, min, max, min. For any polynomial function, the maximum possible number of turns is the degree minus 1. So for our quadratic function, how many turns? Degree minus 1. Of course, it only has a 1 max or 1 min. Degree is 2. 2 minus 1, it can only have 1 turn maximum. It cannot have more. It doesn't have to have. So for example, if we have degree 7, it doesn't have to have turns, number of turns n minus 1, degree minus 1, 6. It cannot have more than 6. But it doesn't mean that if it has degree 7, it must have 6. No, this is the maximum possible number of turns. You may only have 3. You may only have 4, depending on the problem. But it cannot have more than 6. Okay, so let's choose a cubic function. I'm gonna choose the first one and you choose the second. So 41 on page 380. And this is f of x equals x to the third plus 2x squared minus x minus 2. Okay. For linear functions and quadratic functions, we really didn't need to use a table. But here we would use a table of ordered pairs. So the question here is, graph this function. Graph it. Graph f of x. There are a lot of steps here, and we're going to list all of them. Of course, the first step is domain. Can anyone refresh our memory on the domain of this polynomial function or any polynomial function? What is the domain? Please, anybody?
Negative affinity to affinity.
Thank you very much. Good. Number one, domain. You already told me. You don't have to write it again. I'm just listing them now. Once you fill in the table, we're going to be just fine. That will be enough. Number two, x-intercepts. How do I find the x-intercepts for any function, including this one?
Setting the function equal to 0.
Very good. Excellent. Thank you very much. X cubed plus 2x squared minus x minus 2 equals 0. Okay, perfect. So now, a long, long time ago, we discussed polynomials of this kind with 4 terms. What do we need to do in order to find the x-intercepts?
Grouping.
Say it again.
Grouping.
Grouping. Yes, 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 yes. Excellent. Good. Can anyone tell us what to do next? I did something here. Can anyone tell us what to do next? What will you factor out from the first two?
X squared.
Good. What is left in parentheses?
X plus 2.
Very good. What should be left from parentheses, in parentheses from the other two before I even look?
X plus 2.
Indeed. Excellent. Very good. So then what do we factor out? It has to be there. Otherwise, I can factor.
Negative 1.
Negative 1. Good. What factors out now?
X plus 2.
Indeed. And what is left in?
X squared minus 1.
How do we factor x squared minus 1?
X plus 1, X minus 1.
Very good. Degree 3, 3 solutions. Real, imaginary, I don't care. 3 solutions. Can anyone give us those 3 solutions?
Negative 2, negative 1, and 1.
Good. What is the multiplicity of negative 2? What is the multiplicity of negative 1? What is the multiplicity of 1? Meaning, how many solutions I have a negative 2? 1. How many solutions I have negative 1?
1.
Indeed. How many solutions I have? 1?
1.
Good. I put them now in the table in the correct order. Negative 2, negative 1, 0 has to be in the table no matter what, and 1. 0, 0, 0. All these appear once, so at the top I will write cross. Regular cross, cross, cross. Regular cross. No slowing down, no flat, nothing. Just regular cross because all solutions appeared once. Now I need to find the y-intercept. How do I find the y-intercept? That is always easy.
Plug in 0 into
Zero.
Very good. So when x is 0, f of 0 is negative 2. Negative 2. Now I need to determine the end behavior. Good. I know, so that's number 4, end behavior. I know the degree is, again, can anyone tell us the degree of this polynomial?
3.
Perfect. Because it's an odd degree, it can do this or this, depending on the leading coefficient. Now, what is the leading coefficient equal to? What does it equal to?
1.
Indeed. A is 1, which means this. Because if I were to graph a linear function, I would graph it like this, not this. So the end behavior is from negative infinity to infinity. Okay, next step. 5, max min with TI-84. In this class, we don't know. In the next class, we will be able to determine the max and the minimum without a calculator. But in this case, we cannot. So, one other thing that I mentioned, but not clearly, these functions are smooth, continuous functions. No gaps, no jumps. Okay, so now let's look at the table. The table says that the function is coming from negative infinity up to 0. Okay. So from negative infinity crosses the x-axis. It comes back to cross again. So something must happen here. So it's coming from negative infinity crossing the x-axis, it has to come back and cross again. And then it's down to negative 2, and then up to 0, and then probably going to infinity. So with the table, I will plot the points and take it from there. You'll see what happens in a minute. Okay, plot the points first. Negative 2, 0, negative 1, 0, 0, negative 2, and 1, 0. I am going to attempt the graph. So, it's very clear so far, coming from negative infinity and crossing at negative 2, 0. It must, I forgot to mention, what is the maximum number of turns? Number 6. Max possible number of turns. Because the degree is 3, maximum possible number of turns is always 1 less than the degree.
2.
Maximum 2 for this function. Perfect. So let's continue. So it's crossing. It has to have a turn because it comes back to cross again. So here there must be a turn. because it crosses the x-axis at -2, 0, and then it comes back to cross again. So it must be a turn here. Now, it's going down to 0, -2, but I don't know if it turns here, if it turns before, or if it turns after. That part I don't know. This has to be determined with the graphing calculator. However, these graphs have to be smooth, continuous functions. If I have to twist my wrist to graph it, something is wrong. So I'm assuming something like this, it's possible, or a turn at this point, unlikely, but possible, or after. I don't know that part. So for now, I'm just going to say that it turns here. And then it goes up, crosses at 1, 0, no turn, no flat, nothing, and goes to infinity. I doubt that the minimum is here. I'm going to adjust the graph after I look at the graphing calculator. The graphing calculator has to give us this maximum, and we have to find the minimum wherever it is here. And those are the two turns. And we have to put them in the table. So as you see, these graphs are way more cumbersome than the linear and quadratic. They have a lot of different things, like multiplicities, like end behavior, like number of turns, and the max min with the calculator. A lot of work with the polynomials. Okay, so I'm going to share my screen. Let me see the time there. Okay, it's fine. So I'm going to share my screen and go to y equals and put it in. Y equals. Clear? And the function is x cubed plus 2x squared and minus x minus 2. Okay. Now the viewing window, I already graphed the function, so I know what to expect. So I will say negative 10, 10 it's probably good. So I'm going to just graph it. As expected, it's coming from negative infinity. It's crossing at -2, 0. It reaches a maximum, which is a turn. That's what we mean by turns, max min. It crosses at -1, 0. It comes and crosses at 0, -2. As you see, the minimum is to the right. I did not expect it to turn at this point on the y-axis. So here's where the minimum is. And then it goes up. It crosses at 1, 0, going to infinity. I will determine the maximum. It's between -2 and -1. Second calc maximum. The calculator needs help. We're going to tell the calculator to look for it between -2, enter, and -1, enter. I don't want to guess. I'm just going to press enter again. And finally, I get the maximum. The maximum is at -1.55, -1.55, and the maximum is 0.63. Now, I want to determine the minimum. I know the minimum is to the right of 0, but I'm going to put, to be on the safe side, I'm going to put -0.5 to 1. So now second and calc. I will use number 3 because it's a minimum. And the minimum will be between -0.5. It's asking me for a bound between -0.5 and 1. No, I don't want to guess, but I know it's not going to be at 0. I see it. It's not going to be at 0. To the right of 0, yes. 0.22. And the minimum is -2.1. So now I know absolutely everything about this function. I will go back and reinforce. The minimum is to the right. Don't erase anything, that's fine. That was the first assessment. We didn't know exactly if it was doing this or this or this. I was expecting it because it's smooth, continuous function. Again, if I have to twist my wrist, something is wrong. So now we have the maximum, which is negative 1.55, and the maximum is 0.63. That's the point. And now we also have the minimum, which is 0.22 comma negative 2.11. A lot of work with these polynomial functions. So this was degree 3. Degree 4 will be the same. Just the difference will be the end behavior. I know we need more practice, so I'm going to share the book, and you can choose. And we are on page 381. No, 380.